Welcome to lesson number 1 on finance. Today we're looking at simple interest and compound interest as different ways to invest money. So if you deposit money in a bank or other financial institution, you are essentially lending money to the bank. And so in exchange, the bank will pay you interest in one of two ways, either using simple interest or compound interest. So if we were to use simple interest, this is usually applied for shorter investments. So shorter investments that take 1 year or less. And if you're using longer investments where that's paid annually to the investor and not reinvested, again, you're going to be using simple interest. So in this first example, if you invest $500 that earns interest at a rate of 6% per year, how much interest would you earn in 1 year? So in order to find what you would earn in a year, what we take is our principal amount of $500, or our initial investment, which is $500, and we would just multiply this by our interest rate per year. And so in this case, it's 6%. So we just multiply this by 6%, which is 6 divided by 100, or 0.06. This is going to equal $30. So in 1 year, you would earn $30 in interest. Your investment would be worth $530. In half a year, we would take our principal amount, multiply that by our interest rate, which is 6% times 0.06. In half a year, we would multiply it by the time frame, so 0.5. Since it is it's 6% per 1 year, so in half a year, we would have to multiply this by 1/2, or 0.5. This would be half of our investment in a year, which would be $15. And in 1 month, we would have 500 multiplied by our interest rate and multiplied by 1/12. That's per 1 month. This would equal, that divided by, it would be $2.50 per month. Okay, so if R is the annual interest rate, and we express this as a decimal, and P in dollars is the initial investment, we want to calculate how much interest would be earned in 1 year. So in 1 year, all we were doing was in order to calculate I for interest, we were taking our principal and we were multiplying it by the rate. In half a year, we were doing the same thing, but we were taking the principal, multiplying it by the rate, and multiplying that by 1/2. And if we think about the number of years that we would carry over this investment, we would take the principal, multiply it by the rate, and T for number of years, or the time in years. So this brings us to the formula for simple interest, which is interest is equal to principal times rate times the time, where I is the amount of interest, P is the principal amount, or the initial investment, R is the annual rate of interest, rate per annum, or rate per year. This is expressed as a decimal, and T represents the time in the number of years that the money is invested. So let's look at class example number 1, where Millie invests $2,350 at 7% per year for 6 months. We want to calculate after 6 months the simple interest on Millie's investment. So first of all, if we're just calculating the simple interest, we're plugging it into our formula principal times rate times time, and this is going to be equal to the principal amount, which is $2,350, times our rate as a decimal, 0.07, times 1/2 for 6 months. The interest that Millie would earn would be equal to $82.25. Now, if we wanted to calculate what the value of Millie's investment is going to be all we have to do to find the total value is take the principal and add the interest that was accumulated. So 2,350 plus 82.25, we are going to get an answer of $2,432.25. Now, compound interest is another way that we can calculate interest. So with simple interest, the principal or the initial investment at the beginning of the second year is going to be the same as the principal at the beginning of the first year. So your principal never changes with simple interest. However, in compound interest, the interest earned during the first year is then added to the original principal to form a new principal amount. So we'll look to see what happens here in the next 3 pages. But we are going to do that in class. Today I am just doing the class examples. So 467. Class example 2. Now, as we run through the examples and we kind of see the difference that is made, what you're going to notice is that the final amount, is going to be equal to the principal times 1 plus the interest rates, the annual interest rate, and we're going to raise that to the power of the number of years that this investment is carried over for. So in class example number 2, if we have $4,000 invested in a 3-year GIC, and that's compounded yearly at a rate of 3.5% per annum or per year, we want to identify the values for the principal amount, the initial investment, I, this is the annual interest rate, and N, the number of years that this is in this investment for. So P, the principal amount is $4,000. I, this represents, again, the annual interest rate. As a percentage, as a decimal, 0.035. And the number of years we have, this is a 3-year GIC, so that's 3 years. Now what we want to do is determine the value of the investment at the end of the term. So if we plug it into our formula, A is equal to P times 1 plus the interest rate to the power of N, what we are going to get is the value of P, which is 4,000. My rate, 1.035. 1 plus I is 1.035 to the power of N, which is equal to 3. And we want to go to the nearest, well, we're just going to go to the nearest hundredth. That makes sense. 4,434. Looking at class example number 3, Reina has invested $8,000 in a 5-year bond, and this is compounded annually at a rate of 3.2% per year. We want to determine the interest earned at the end of the 5-year period. So we're looking for the interest earned at the end of the 5-year period. So let's identify the value of P. P is equal to 8,000. I is our rate, which is 3.2%. And the number of years here, N, is equal to 5. So A is equal to P, 1 plus I to the power of N. P is equal to 8,000, 1.032 to the power of 5. Our value of A is $9,364.58. Now, in this question, we're not looking for the final amount. What we're looking for is just the interest at the end of 5 years. So what we need to do to determine the interest is we just subtract the principal amount. So the interest is going to equal the value of A minus P, which is 9,364.58 minus 8,000. This will be equal to $1,364.58. All right, last example that we'll take a look at. Amberlynn invested $8,000 in an investment for 5 years, compounded annually at a rate of 7.25% per year. We want to determine the value of her investment at the end of the term. So, taking a look at the value of A, that's equal to 8,000 times 1.0725 to the power of 5. So it's compounded, so we know that we have to use our compound interest formula. So 8,000 times 1.0725 to the power of 5. We get $11,352.11. We want to calculate the profit that she made on her investment. So she invested $8,000. This is what she made. So in order to calculate the profit, we're just going to subtract the amount and her initial. So $3,352.11. Oh, that was not what I wrote though. $3,352.11. Now, suppose that Amberlynn has not decided how long she will keep the investment. Let X represent the number of years that her money is invested. And we want to write an equation in the form y equals AB to the power of X to represent her balance after X amount of years. So after X amount of years, Y would equal 8,000 times 1.0725, where X is the number of years. So it'll look something like that. If we graph the equation in part C with the window settings here, what do the numbers on the x-axis represent? So we want to graph this equation, and raise that to the x power. And we're going to have to change our window settings here. Right now, we won't even see the graph showing up. So for my for my x-min, it's a 0, 10, scale of 1, 8,000, 18,000, and 1,000 for my scale. Okay, so now we see our line forming. So the values on the x-axis, these would represent the number of years since x is taking the place of time. This is the number of years the money is invested. And the numbers on the y-axis, these represent the value of the investment. So what we could do here, we could use our calculator. So if I use my trace function and I wanted to find out when x is equal to 10 years, for example, then the value of y would equal $16,108.79. So Amberlynn wants to know which of the following options will increase her investment more. So if she increases her initial investment by $500, or finding an investment with an annual interest rate of 8%. So for each of these two scenarios, we want to write an equation to represent her balance after X number of years. So in the first scenario, our equation would change to this, 8,500. The rate is the same to the power of x. If we change from an interest rate to 8%, y would equal the initial principal investment times 1.08 to the power of x. Now we want to graph the two equations on the same axis as our graph from part D. And we're going to compare the differences in our graphs. So here are our new equations. So this is with the principal amount equal to 8,500. So if she just increases her principal amount, and now we should see the other line popping up here. And so the other line pops up here. This is if she has 8% interest. And so right now, I'm going to have to probably zoom out a little bit, but right now it's appearing that the graph that has a larger initial amount starts out with a bigger value. But when we have the larger interest rate, this one tends to increase faster. So here's where it starts to increase faster at this point here. What we would probably have to do is zoom out to see if our second scenario would actually pay out better in the long run. And it kind of depends on the time frame that we're talking about here. So if we describe the two differences between these graphs, if the initial investment of $8,500, the graph with the larger investment starts out with a higher value, but the graph with tends to increase fast. With the higher interest rates, tends to increase faster. Now, if she wants to cash out her investment after 5 years, we want to determine which is the better option. So in 5 years, which is the better option? Now, we could use the graph, but we could also just plug this in to our equations here. So let's look at this equation here. So we have 8,500 and times 1.0725 to the power of 5. So if we have a principal amount of $8,500, then, and I'll just call this number 1 and number 2. So with number 1, this would equal $12,061.61. And 2 in 5 years would be worth $11,754.62. So in 5 years, she's better to go with option 1 with the larger or the higher initial investment. Now, if she wants to cash out her investment after 10 years, let's see what that looks like. So after 10 years, with the first option, she would cash out at $17,115.59. And option 2, it would be $17,271.40. So for 10 years, she's better off with option 2. And this is kind of how or the main difference between simple and compound interest is just the time frame we're looking at.